So there are different kind of use cases where one of these or another might make sense. There's also a variation, which is, I'll say, call every n. And we should talk more about that in a minute too. I wouldn't call that 5. I'd call that maybe a variation on these themes. So why would you ever not want to call getLastError and get a result back? Well, here's a use case for you. So imagine that we're serving a web page to a user, right, on our website. And while we're doing that, or right before we return, we'd like to increment a page view counter for this section in a collection of page views somewhere. Or maybe we just want to log something that's system information. You know, the question is twofold. One is we're going to increment this page view for internal, monitoring. If we get back an error, what are you going to do differently, right? Are you going to report it to the user? No, because the user doesn't care about your page view counters. You might want to get that error back so you notice something is wrong, of course. And we can talk about that with this pattern, if you will, in a minute. So there's kind of a way to get there anyway on that. So this sort of thing, page view counter, where there's no user impact, might be one of those. If you have for example, I got my app server here, I've got my database, Mongo here, let's keep it simple and draw one. We got the client out here, right, on their web browser. So they've made this request in HTTP, and then there's any number of back and forth queries, writes, whatever going on here before they get a response. Well, if we sent this increment of a counter, that's going to take almost no time if we don't wait for the response. But then if we say, give me back that result, acknowledge it, well, that's going to take some time. If these are on the LAN, that round trip, even if the database is infinitely fast, could be on the order of 1 millisecond, for example. So I'd be adding 1 millisecond to the user's response time to do that, which is not too bad. But if I had different databases here, right? If I had a core DB for the users and maybe some CMS or something. If I have one over here, which is just the page view counters analytics database we use, and you could imagine it's 1 millisecond away, but maybe it's slow, right? Maybe it's acting up and it's slow. Then I could get a big delay here. The other thing that could happen is, imagine in my stats database where I'm keeping these page views, I actually want to increment 10 things, right? Or update 10 things, yeah. All these different metrics, counters, statistics, database fits in RAM, so you could get pretty high performance that way, even though, I've got an ink of this thing, an ink of this, and they're not the same document, so it's not one request. And I go down the line, so there's 10 of them, right? In Mongo, it's fast enough in some situations like this where this is perfectly reasonable, right? However, if we had this sort of thing going on, do the ink via an updater, an upsert, and then get an acknowledgement, back, 10 times. Now we're up to 1 millisecond times 10 equals 10 milliseconds. So now it's starting to add up. And you might say, well, why did you do that? Why in the world would you do 10 updates on a single page view? And the answer is because if I don't do all this back and forth and this fits in RAM, I actually can. So I think in traditional databases, there was a engineering trade-off, a pro and a con, is that these were the default. And then that's good for safety, because if the user makes a mistake and they use that default and they shouldn't have, that's bad. But the good thing here is I can do this, and it lets me do things like that, which perhaps would have been too expensive in the past. And this little thing here, the call every n, we'll talk about that in a minute, is another pattern that can kind of let you have a little bit of the best of both worlds. Not totally, but this is definitely an example of something like that. Another one that would fit that fire and forget mold, perhaps, would be logging. So imagine I write a logging service for my data center or my system, and it's a structured event logging, or logging these JSON or BSON things, and it gives me a nice centralized log, right? Well, I don't want to slow the user down just because I'm writing to the log service. I really don't want to do that, but I do want to have a log service. And maybe I write the log event to the log service. Maybe I also write it to a log file on the local machine. That way, if the log service is ever down, I still have some record of what happened there. So that's a good pattern, I think. So that sort of log service case, I think, is a pretty good one for this no call at all case. The W majority, I think this is most things. And another way to think of it is important things. If I do anything important, you want to use W majority, right? Things that cannot be lost. You'll get the true commit acknowledgement for the whole cluster. Even if, if we had 3 servers, one is gone, burned up in a fire, I got W majority back, guaranteed to still have the data. So that's pretty good. To go to all, I think, it's almost not a data safety thing, because majority is pretty good. All is probably more for, it's almost like a flow control thing. I want to wait until all the servers are caught up. I don't want to let any of them lag before I continue. So for example, if you were doing a bulk import of 1 billion documents, and you wouldn't want one member of the set to start falling behind. Maybe it's a little bit slower machine. Maybe there's 0.1% packet loss on its network adapter, and we didn't notice that, and it starts falling behind, and that's bad, right? So we wouldn't want that to happen. So we could use this all acknowledgement to wait until the slowest member gets the data. And hopefully they're all the same speed, but it's a way we can kind of guarantee that. And while waiting for all is kind of slow, if we couple it with the call every in pattern, it'll be much better. So we'll look at that in a second. W1 is good for writes that are not super critical, where you care a lot about write availability, perhaps more than durability a little bit. I mean, you're going to get an acknowledgement from at least one server, and then hopefully the data is on the best effort getting out to the other ones really darn quick. So it's not bad. It's just not a true commit acknowledgement. But it's good for if you need to get things back like dupe key. Like say you want a dupe key notification, dupe key constraint violation notification after an insert, and that's the main thing you wanted. You're not really so worried about full cluster-wide commit. That would be a good use case for this. It's a good way to just check that basic stuff is working without waiting for the whole cluster. Perhaps you're doing some caching and you're storing data in Mongo as a cache, therefore the data, it's not that critical. I think you could either go with the no last error or W1, depending on what you're doing. Okay, so that's some of our options here. There is another option. So the variation can kind of be applied to all of these where we make any call at all, or even arguably to the first one where we only make a call every nth. So it's a little bit orthogonal option to those. There is another option here, which is to use a tag. So with the tags, you might want to say, look, I want acknowledgement when this is made it to 2 data centers or 2 racks or both. That is a possibility also. Okay, let's talk about this thing here at this point. Call every in. So in this model, we do something like the following. I'll just write some pseudocode down here. What we could do is we do our write. So maybe we're going to do insert, update, whatever it is. Let's just say it's an insert here. Say I have some array of these things. And then I could do something like I would check that and then presumably report it if something is wrong. And so here we have a situation where we're not calling this constantly, but we're calling it periodically, right? So you could imagine in a batch operation that an operation fails and we don't see that here, right? But if everything is failing, it's going to show up here. In particular, if we're a little careful about what we're doing and did something like this. So we have these 100,000 items to add. We insert one, insert them all in the loop, 100,000 of them. If this equals 0, I mod 500. So for 0, it will be basically for all everything divisible by 500. We're going to call get last error. So every 500th one, we're going to call it. In addition, I've been kind of careful and made sure that this is true when I equals 0. So it's going to get called on the very first one. I think that would be nice. Imagine if this batch was small, if we were only doing 200 of them and it never got called, that would be bad. And this really is, we can make this a little nicer. Let's actually do this. Let's say we have n of these, where maybe n is 100,000. And this was an I. I equals n minus 1. Okay. So every 500th one we're going to call this, and it just so happens we're going to call it on the first one, after the first one. And then on the very last one we're going to call 2, because I think that would be good, because you know, if we've got these writes to do, you know, every nth one we're going to make a call, but I'd also like to make one on the last one, and maybe the first one. I think that would be ideal on a big batch job. Now, of course, depends what I'm doing here, right? If these are all banking transactions or something, you know, I probably should be calling this every one, right? It depends on the criticality of the data and how I want to view it. So this pattern is sometimes appropriate, not always. You know, another way to go though too is to keep in mind is there's a variation here that's a little stronger in terms of reliability, which is, okay, so here we've done the same idea again, but every nth we're making a relatively strong acknowledgement call, and then on the other ones we're making a lighter one that presumably is faster. So you could imagine something like this, or you could imagine doing, we could do something like all the members here. So if we had 3 in the set, we could do 3 here. And now one reason we might do this is we're just waiting for everyone to catch up. We don't want to get them behind, right? And in addition, we're getting a really strong acknowledgement when we get that. And then, but we don't do that every time, so that we can get a little bit of throughput and going on the system. So this pattern can be pretty good. You know, generally if things fail in the middle, it's sort of, well, why did they fail in the middle and not at the other points, right? So would be the question. So that can definitely happen. It depends on what you're doing. I mean, certainly like on a unique key constraint, that would be very easy to happen. But I think this would give you a decent sense of this kind of thing.